I'm Kevin Binkley.
And I'm Jason Leonard, technical trainers here at A.O. Smith University. And we'd like to welcome you to today's module on basic gas water heater installations. Faulty installations can greatly affect a water heater's operation and performance. Knowing how installers are trained and the standard procedures used to install gas water heaters can lead to quicker and more accurate problem diagnosis and fewer customer callbacks. Let's take a look at a short video we use to train installers.
Install the new water heater in a drain pan, pipe to a drain. Install the air filter. The air filter should be vacuumed occasionally to remove dust and lint. Your new water heater must have a new temperature and pressure relief valve. Don't reuse the old one. Use the new one that came with your water heater. Next, install the discharge pipe. The discharge pipe must stop no more than 6 inches above a floor drain or outside. Many codes now require a pressure-reducing valve, a thermal expansion tank, and thermostatic mixing valves. If your home has copper pipes, you may be able to use compression fittings that don't require soldering. If you plan on soldering pipes, do not solder pipes while the pipes are connected to the water heater. Water heater connections contain plastic parts which will be damaged. Instead, solder a short piece of pipe to a threaded adapter. Put Teflon plumbing tape on the inlet and outlet connections and attach the threaded adapter. Cool the adapter with wet rags while soldering. Next, install the new draft hood. Do not reuse the old draft hood. Use the new one that came with your water heater. Use sheet metal screws to secure the draft hood to the top of the water heater and to attach the vent pipe to the draft hood. Install the gas pipe using pipe joint compound, taking care not to get the pipe joint compound inside the gas pipe or the gas valve. Turn the gas supply on and check for leaks using gas leak detection solution. You can make leak detection solution using 1 part hand dishwashing soap and 15 parts water. You can also use children's soap bubbles. Brush the hand dishwashing soap solution on the gas line connections and look for bubbles. Because gas pressure is low, it may take some time for bubbles to appear. If you see any bubbles, turn the gas supply off, then correct the leak and retest. Turn the cold water supply back on and check for water leaks. Most leaks are at connection points and are not a tank leak. Open a hot water faucet. At first you'll only get air, then a few spurts of water. Wait until the water flows full stream. Then let the water continue to flow full for 3 minutes. Check the water pipe connections and retighten if necessary. Drips from the temperature and pressure relief valve are usually caused by high water pressure or thermal expansion. If your old water heater was leaking, your water pressure may be too high. Check your home's water pressure with a gauge. If the pressure is above 80 pounds per square inch, install a pressure-reducing valve. Water expands when heated, and thermal expansion can damage the water heater's tank and cause it to leak prematurely. Protect your water heater and your home's plumbing system with a pressure-reducing valve and a thermal expansion tank. This water heater has a new advanced gas valve, and lighting the pilot is different than on older models. To light the pilot, follow the lighting instructions on the water heater's label. Turn the control knob to pilot and press the knob in fully. Hold the knob in and click the igniter button about once a second until the status light begins to blink. It may take up to 90 seconds until the status light begins to blink. The status light will blink once every 3 seconds when the water heater is operating normally. With a new water heater, it may take 2 or 3 attempts before the pilot lights. One flash every 3 seconds means the pilot is lit and the gas valve is working normally. A solid status light means the water heater is shutting down. Turn the gas control knob off and wait 10 minutes before attempting to relight the pilot. The status light will flash more than once every 3 seconds if an error is detected. Refer to the troubleshooting section in the installation instructions if an error flash code is displayed. When the status light is blinking once every 3 seconds, release the knob and set the temperature to the desired setting. We recommend a maximum temperature setting of 120 degrees. The water heater's thermostat should not be the only temperature regulating device in your home. Install thermostatic mixing valves at each point of use to reduce the risk of scalding. See the water heater's labels for important safety information.
One complaint with newly installed gas water heaters is what may appear to be a leak. Almost all leaks from a new water heater are not tank leaks, but rather loose plumbing connections or condensation which form during the initial heating cycle. Let's take a look at this short video about leaks.
All new gas water heaters produce condensation the first time they're started. You may hear dripping sounds coming from inside the water heater. You may even see a small puddle in the drain pan. Sometimes condensation can drip on the burner and you'll hear a sizzling sound. It's normal for a new gas water heater to produce condensation, but it's important to note that condensation is not a leak, and it will disappear once the water heater reaches normal operating temperature. Leaks from a new water heater are almost always caused by plumbing connections or fittings, not the tank. Check inlet and outlet connections and tighten or repair if necessary. Drips from the temperature and pressure relief valve are usually caused by the home's water pressure being too high or due to the lack of a thermal expansion tank. Never cap or plug the discharge pipe. If your temperature and pressure relief valve drips, check your home's water pressure. Adjust the home's pressure regulating valve. The recommended pressure is 50 to 60 pounds per square inch. Higher pressures can damage the plumbing system. A thermal expansion tank is now needed on most water heaters and is required by many local codes. Be sure and read the installation manual for important operating and safety information.
Be sure and check for leaks around the inlet and outlet water connections and all threaded fittings. If you find a leak, clean the threads, apply thread sealer, and retighten. And keep in mind that all gas water heaters produce condensation during the initial heating cycle or any heating cycle thereafter if the entire tank is full of cold water.
Another common issue with newly installed gas water heaters is the dripping temperature and pressure relief valve. Dripping T&P valve is most likely a result of high water pressure or the lack of a thermal expansion tank. High water pressure and thermal expansion may also lead to other more serious problems like premature tank failure or even water pipe damage. Here's a quick video about troubleshooting temperature and pressure relief valves.
Drips from the temperature and pressure relief valve are usually caused by the home's water pressure being too high or the lack of a thermal expansion tank. Never cap or plug the discharge pipe. If your temperature and pressure relief valve drips, check the pressure with a water pressure gauge. Adjust the home's pressure regulating valve. The recommended pressure is 50 to 60 pounds per square inch. Water expands when heated and can also cause drips if a thermal expansion tank is not installed.
Remember to check the home's incoming water pressure with a water pressure gauge. If the water pressure is more than 80 psi, install a pressure reducing valve and set it to between 50 and 60 psi. Water expands when heated, putting excessive strain on pipes and a water heater. A dripping temperature and pressure relief valve is a sure sign the home needs a thermal expansion tank. A properly sized thermal expansion tank like this one should be installed at the same time as the water heater and is recommended for all installations. Now let's watch this short video about thermal expansion tanks.
Water expands when heated. A 50-gallon tank of cold water becomes about 52 gallons or more when the water is hot. In the past, this extra gallon or two made its way back into the city water supply every time the water heater ran. But changes in plumbing regulations required that backflow preventers or check valves be added to homes and businesses to keep the water in your home from possibly contaminating the public water supply. When the water expands now, it has no place to go, which greatly increases the pressure in the water pipes, damaging plumbing, appliances, and water heaters. Drips from the temperature and pressure relief valve are now much more common because of thermal expansion, and the best solution is to install a thermal expansion tank. To install a thermal expansion tank, first determine the water pressure in your home. Use a pressure gauge with a recording hand and check the pressure for a 24-hour period. If the water pressure is greater than 80 pounds per square inch, install a pressure-reducing valve. The recommended water pressure is between 50 and 60 pounds per square inch. Expansion tanks contain an air bladder, which is pressurized with air and expands and contracts to absorb water from the water heater. Expansion tanks are sized based on the number of gallons in the water heater. Most residential expansion tanks are 2 or 5 gallon. If in doubt, use the 5-gallon expansion tank. If the tank is too small, it won't work. To connect the tank to the cold water line, solder a T-fitting or use a saddle valve that bolts on. No soldering needed. Check the air pressure in the expansion tank using a tire gauge and adjust the air pressure to equal the maximum water pressure in the home. Use a hand pump, not an air compressor, or you may rupture the bladder. Install the thermal expansion tank on the cold water line. Remove trapped air from the other side of the bladder by turning a water faucet on until a steady stream flows. The expansion tank will give the expanded water somewhere to go, helping prevent damage to pipes, appliances, and the water heater. Thermal expansion tanks will also help prevent nuisance drips from the temperature and pressure relief valve.
Even if there is a thermal expansion tank installed, it may not have been charged to the correct air pressure. Use a hand pump or an air compressor to properly charge the thermal expansion tank with air to match the home's incoming water pressure. Remember, high water pressure and thermal expansion are problems with the home's plumbing system, not the water heater, and are not covered under the water heater's warranty.
Installers also need to make sure they don't solder the inlet and outlet water pipes while they are connected to the water heater. The water heater's connections have plastic parts that may be damaged. When making water connections, we recommend soldering a short piece of pipe to a threaded adapter away from the water heater before making the connection.
It's also important to make sure the home's inlet gas pressure is in the correct range. The minimum and maximum inlet gas pressure requirements are stated on the water heater's data plate. Most basic gas water heaters require a minimum inlet pressure of around 5 to 6 inches of water column, but some are different, so always refer to the data plate. Inlet gas pressure needs to be at least 1 inch of water column higher than the required manifold pressure. This is to allow for the pressure drop across the valve. When checking gas pressure, you always want to make sure to take a dynamic reading, meaning that all gas burning appliances are running while taking the measurement.
A common oversight during gas water heater installation is neglecting to make sure the installation has access to adequate combustion air. Due to today's tighter home construction requirements, It has become increasingly difficult for gas water heaters to operate properly without access to outside air. The combustion air demands of additional gas burning appliances in the home may also result in not enough air for the water heater to operate correctly. An installer may mistakenly overlook proper venting practices when installing a gas water heater. Today's gas water heaters are more efficient than older models. This means that more of the heat is being transferred into the water rather than escaping through the venting system. This practical design results in relatively low flue gas temperatures exiting the water heater. Since cooler flue gases rise slowly, it's important the water heater's venting utilizes the straightest, most direct route out of the house. This will help ensure all flue gases are safely expelled to avoid flue stall. Numerous 90-degree elbows and exceptionally long horizontal vent runs are some of the more common venting mistakes.
A lack of combustion air or improper venting practices may cause the combustion chamber to get too hot and trip the water heater's thermal switch, shutting the water heater down. To help avoid combustion air related issues, refer to the combustion air and ventilation section of the owner's manual to determine proper combustion air specifications and venting requirements. A simple way to determine if the water heater has enough combustion air and is venting properly is to do a simple draft test.
To correctly perform a draft test, close all the home's windows and doors and turn on all the exhaust fans and air handling devices. Light the pilot and adjust the thermostat to hot to light the main burner. Allow the burner to run for 5 minutes and then hold a newly extinguished match about 1 inch from the draft hood's opening. If the smoke is steadily drawn into the draft hood and up the vent, the water heater is getting adequate air and the vent system is working properly. If the smoke hovers around or is blown away from the draft hood's opening, the water heater may not be getting enough combustion air, or the vent may be obstructed.
Thank you for completing this module on gas water heater installation. In the next module, we'll cover gas water heater troubleshooting. Until then, this is Jason Leonard and Kevin Binkley from A.O. Smith University. If you have any questions about this material, email us at university@hotwater.com.